DPI, IDS, IPS, and the smart queues. They are all very useful features in UniFi routers. DPI means Deep Packet Inspection, IDS and IPS means Intrusion Detection or Prevention System, and the smart queue is used to improve the internet latency. They are all very useful features in UniFi routers, but many people have concerns about whether they should enable them. They worry about whether it will impact internet performance. In my previous videos, I already covered DPI, IDS, IPS in one video and the smart queues in another video. In those two videos, I talked about how they work and what's the performance impact individually if you enable them. But in those two videos, I didn't enable them all because of a reason. In my opinion, yes, they may all impact your internet performance, but due to different reasons. For DPI, IDS, and IPS, they may harm your internet speed just because they will consume your computer resource, the hardware, software. Your router may be busy doing some additional tasks, so that's why it may not have enough resource to cover the internet part. But smart queues, just due to the way it works, it has to reduce your internet speed a little bit. It's not because of the hardware resource consumption, it's simply because of how it works. If you are interested, check my previous video. In this video, we are only going to focus on the internet speed testing. Having said that, let's have a video anyway. Let's enable all of them among 4 different UniFi routers. Let's see whether the internet speed will be impacted. If yes, how much? I have set up 4 almost identical lab environments for the 4 different UniFi routers. The oldest USD3 Pro, UDM Pro, the new UX3 Pro, and the latest UDR. So let me pick the UDM Pro as an example. I use pfSense to connect to the real internet. But for the testings in this video, all the so-called internet traffic, in fact, they are inside my lab. I connect my UniFi routers plus its associated switches with my home network. Then I make sure the server machine, which simulates the internet server, it has the IP address for my LAN network, which means whatever I'm going to test, all the traffics are within my home network and lab. They are not going through the router. So my real internet speed and my pfSense box are not factors for this testing anymore. When it comes to each specific lab environment, it's super simple. Just one switch, one router. Some UniFi routers have 2 WAN ports to connect to internet. For example, the UDM Pro has a gigabit one and a 10 gigabit one. But because this video is to enable all the settings, including smart queues. If you are familiar with UniFi smart queues, you may know the maximum internet speed, the upper limit is 1 gigabit. So it doesn't make sense to test the 10 gigabit one in this video. So throughout the video, I'm only going to use the 1 gigabit port. I will use this type of screen layouts for the testings for UniFi routers. This one is for UniFi controller, and then I will have a SSH session into the router just to show you the router load. I will have a Linux virtual machine to simulate internet server, another Linux machine to simulate the LAN client. Because I have 4 parallel LAN environments, so in total I have 12 client Linux virtual machines plus a server Linux virtual machine. So in total, I'm running 13 virtual machines now just for this video. Okay, now it's time to start with the oldest one, the USD3 Pro. This is the diagram for the USD3 Pro testing environment. I have the gigabit one part connected to my home network to simulate internet, and then for the LAN it will have subnet 1. For internet it will have subnet 2. Because it's UX3 Pro, I have to run a separate virtual machine just to host the UniFi controller. So in total you will see 3 Linux virtual machines in client side, 1 Linux virtual machine in the server side. Before we enable everything, let's test the default internet performance. In the left side window, you can see I'm in the settings screen. I go to DPI. By default, it's enabled. Go to thread management. As you can see, by default, the IDS or IPS is disabled. Then go to internet. The smart queues by default is disabled. Let me log on to the router using SSH. Okay, then I will run top 99% is idle. Nothing's really running. Let me run 3 different IPS3 servers. The reason I already explained it in my previous videos, basically just to increase the parallel running sessions. I launched 3 separate terminals. The first one listening to port 5201, second one 5202, third one 5203. Because I still have some room, so in the background I'm displaying the system monitors so you can see the current network speed. Okay, we are good with the server. Now let's launch the 3 IPS3 clients in the client Linux virtual machine. In the left side Linux server, let me get the IP address 2.102. So in the right side, in the Linux client, I already typed the commands for the 3 IPS3 sessions. Server machine IP is here, and capital letter P 10. I just want to increase the parallel connections. Part for the first IPS3 servers, I'm not specifying the direction, so by default the direction is sending. If you think from internet usage perspective, that means we are testing the uploading speed. Let me run the first one. You may see from the server side close to 1 gigabits already. Let me continue to the second client. This time the port is 5202. I just corrected the port number error in the left side. Now let me rerun the second command in the client side. Okay, it's running. The total throughput is not increased at all, but at least it's running. Let's check the router SSH. You can see it's still 70% idle. It's not busy at all. Then move on to the third one. All the 3 sessions are running fine. But remember, we also want to test the smart queues, right? So that's why I have the 4th terminal launched in the client side. Let me ping the server. Yeah, it's pingable, but the latency is not good, more than 10 milliseconds. Let me kill the other IPS3 session. As you can see, the other 3 competing IPS3 connections dramatically harm the latency. That's the buffer bloat problem. Just to make it complete, let's test the download scenario. Let me specify capital R. Let's test downloading. You can see it's almost the same as uploading, close to 1 gigabits. Latency situation, we are testing downloading now, so it's different than uploading, but still it's impacted by the competing internet sessions. So we are good with the testing before we enable all the settings. Let's move on to enable IDS, IPS, and smart queues in the UniFi router. You may remember for DPI, by default, it's enabled. Then go to IPS. Let's enable everything, right? Okay. We haven't enabled smart queues yet, but if you check the right side, the router is super busy already. There's almost no capacity anymore. One of the busiest process is Sarikata, which is for IPS. Because I haven't queued all the IPS3 sessions, as you can see, they are still running, but the speed is already very bad. It's slower than 500 megabits already. Keep in mind, I even haven't enabled the smart queues yet. From the ping session, as you can see, the latency is more than 20 milliseconds already. Now let's try to enable smart queues to see what's the change. Go to network, internet setting. enable smart queues. Even before we enable smart queues, the internet speed already dropped to lower than 500 megabits. It doesn't make sense if we set the rate to higher than that, right? Then let's try to set both of them to 400 megabits. Save it. Let's see whether it will change our internet speed and whether it will change latency. So even after I already changed the smart queue settings to a very low rate for both download and upload, the internet throughput are still not changed. Let me try to queue all the IPS3 sessions just to free up the router resources. From the SSH, you can see it's slowly back to normal. Even though there's no any real internet traffic yet, the router is still super busy on the IPS part. Now let me try to run the same command again. Let's see whether my smart queue setting can take effect. See, from the server side, the total throughput is close to the download rate and upload rate which I set in smart queues, right? In the right side, as you can see, the ping session, the latency is also dramatically improved. This is just the download scenario. I won't waste your time to test the upload, but it's a similar situation. The second router we are going to test is UDM Pro. This is the network diagram. It's very similar to UX3 Pro. Here I replaced the switch with a 10 gigabit switch. It's not really necessary because we are only going to test the 1 gigabit internet part. UDM Pro runs its own controller by itself. We are going to use the exact same server to simulate the internet server. Let's go to the system. We are going to repeat the same steps as we did for UX3 Pro. We keep the default setting, which is for DPI by default is enabled. For IDS, IPS by default is disabled. And for internet by default, smart queues is not enabled. I already prepared all the 4 windows already. So for the SSH, as you can see, now the router is pretty idle, 77% idle. In the server side, there's no traffic. Now let me launch the IPS3 testing. It's super busy already, and the total throughput is close to the upper limit, 1 gigabit, which is good. In the router SSH part, as you can see, it's not busy at all. Of course, it's a modern router. It's more than capable handling this type of internet traffic. In the fourth client-side terminal, let's run the ping command. Okay, this time you see the big difference, more than 100 milliseconds. Just to compare, if without the competing internet traffic, let me queue the other 3 IPS3 sessions, the latency is less than 1 millisecond. That's the difference. That's the issue if you do not enable smart queues. Let me run the 3 IPS3 sessions one more time. Now the latency is back to the very bad situation, right? Let's enable all the settings in the controller and enable smart queues. Let's see whether it changed anything. For DPI, by default is enabled already. Let's go to IPS, enable IPS, and enable all the features. Apply. Let's see whether the total network throughput is impacted at all. In the SSH part, you can see the number 1 process is Sarkata, which is for the IPS. Makes sense, but the total router load is not heavy at all. It's still pretty idle. And in the internet ping part, you can see nothing's changed because we haven't enabled smart queues yet, right? That also makes sense. At least by enabling IPS, the router can handle it without problem and your internet speed won't be impacted at all. Now let's enable smart queues. For reasons I already explained in previous video, here let me pick 85% of the total upper limit. I set both to 850 megabits. Save. After it's enabled, I expect the total throughput to be dropped to the rate I just set, and the router can still handle it without problem. But let's see whether that's the case. Yes, you already see the effect. The total throughput is dropped. It's close to 850, and the router is still 25% idle. If you check the ping session here, you can see the latency is dropped to less than 1 millisecond, right? That's the effect of smart queues. Basically, it resolved the buffer bloat problem already. Conclusion for uploading for UDM Pro is, if you enable all the settings, they still work fine. The router can handle it without problem. Let's try downloading just to make this testing complete. Let me specify R for all the 3 IPS 3 sessions. Now we are testing downloading. You can see the change in the server monitor already. So see the red line is for our clients downloading. For server, of course, it's sending. Speed is a little bit lower than upload. It's good enough. Let's check the ping. It is still lower than 1 millisecond. The smart queues still work fine for download. Okay, we are done with the UDM Pro testing. So the conclusion is, yes, you can enable all of them and they all work fine. Now let's move on to the third UniFi router, UX3 Pro. The network diagram is almost identical to the one for UDM Pro. The only difference is I need to run a separate Linux machine just to host the UniFi controller. Let's go to the environment. Similarly, in the UniFi controller, I make sure all the settings are default. DPI is enabled, IPS is disabled, and smart queues is disabled. In the SSH, you can see it's super idle for the router. There's no traffic in the server side yet. Now let me start the first IPS 3 running, second one, third one. They are all running. Let's check the SSH for the router. It's nothing for the modern hardware. It can handle it without any problem. The total throughput is close to 1 gigabits. Everything is expected. Now let's start the ping to see what's the network latency. Okay, the same case as in UDM Pro, more than 100 milliseconds. So it's bad. Now let's enable IPS first. I select all the categories, apply setting. I don't expect too much change in the total throughput because we haven't changed the smart queue setting yet. I also expect the router can handle it without problem, but give it some time. Now, as you can see, the top process in the router side is Sarikata, which is for IPS. The total internet throughput is still close to 1 gigabits, very stable. The ping latency is still more than 100 milliseconds. Just by enabling IPS, yes, it will consume some router resource, but the router can handle it without any problem. Let's enable smart queues. Let me enable it, and for speed, let me set it to the same value as in UDM Pro, 850 megabits. Okay, save. See a different effect if you compare to the UDM Pro. Every time I change the setting in UniFi controller, my IPS 3 session will be broken. You can see the error, connection reset by peer. Apparently, Ubiquiti has some different implementation in the router side. Once the setting is changed, the router's traffic will be temporarily impacted for UX3 Pro. That's interesting, but let me restart the settings. As you can see, the total throughput, very similar situation if you compare to UDM Pro, no surprise. If you check the ping session here, again, the latency is dropped to less than 1 millisecond. Of course, the latency situation is dramatically improved just because we enabled smart queues. It works almost identical if you compare to UDM Pro. The only difference is every time after changing setting in UniFi controller, somehow the IPS 3 sessions were broken. I need to restart them. The last router for today, the UniFi's latest small UniFi Dream router. I'm not using separate switch because the router itself has a small switch already. I connect to similar Linux virtual machines for client and server. It has similar IP address settings for WAN and LAN. Because UDR doesn't come with the so-called legacy or old user interface, so I have to show you the settings in a not very convenient way in the new UI. For IPS, as you can see, I already turned it off. For smart queues, it's already disabled. In the SSH part, yes, the router is pretty idle. In the Linux server side, you don't see any traffic. Now let me start the three IPERV3 client sessions. First one, second one, third one. You can even tell from the client side it's super slow. From the SSH, you can see it doesn't refresh, has huge delay even just to refresh the top session. At least if you check the total throughput, it's still acceptable. It's close to 1 gigabit. Let's start the ping to see what's the latency. Okay, it's super huge, more than 300 milliseconds. In real world, you will have significant issues if you use, let's say, Zoom or Skype meeting. Now let me turn on IPS. Select detect and block, then select high sensitivity, which means all the threat categories will be enabled. Apply changes. See the button color, it doesn't get back to the original light blue color. It implies the router is still busy trying to respond, but it hasn't yet. And you can even tell from the right side, I don't see the Sarikata process name, which means the IPS is not really enabled yet. So basically, because the router is so weak when it comes to hardware, it simply doesn't respond when it's super busy. So the way to make further controller setting change is I have to kill the existing IPERV3 sessions just to free up system resource. The system is responding. Let me try to set the IPS setting one more time. This time, I believe the controller is trying to do the provisioning. Let's see whether in the SSH part, we can see Sarikata. After more than a minute, finally I see the Sarikata, which means the IPS now enabled. If I run IPERV3 again, I will see worse internet throughput, just because the router cannot handle it. But let's see, there's no any available free resource. The total throughput is still okay. It's still about 800 megabits. It's working at least. Let me validate the ping latency. Yeah, still very bad because I need to make another controller setting change just to avoid the long waiting. Let me kill the IPERV3 session one more time. Then let me go to internet. Let me change the smart queues. Let me enable it. Remember, it seems it can still handle the 1 gigabit uploading speed, right? So let me try to set it to 800 to see whether it can achieve this upper limit. Now let me start the IPERV3 client again. This is some new effect or problem we didn't see in my previous videos. Before you enable smart queues, you can still achieve more than 800 megabits uploading speed, right? But after you enable smart queues, just because the router need additional resources to deal with the smart queues, it make the burden even heavier, network latency even worse. And now if you check the total throughput, it's even dropped to about 600 megabits, which means after enabling smart queues, not only it doesn't improve your latency, it even reduced your network speed. Again, blame the weak hardware, right? Apparently the smart queue setting, the 800 setting doesn't work for this UDR. Let me kill the IPERV3 client, then try to set the smart queue setting to a lower value. Remember the total throughput was close to 600, right? Let me try the upper limit of 500 because you expect your setting to be a little bit lower than the real speed, right? So let me change them to 500. Give it some time to make sure they are effective. Start the IPERV3 the fourth time. Total throughput is over 400, lower than 500. And then let's see what's the ping latency. Okay, finally, you can see now its latency is super low already, which means our settings in smart queues work. It improved the network latency, it resolved the buffer bloat problem, but as you can see, it dramatically reduced the total internet throughput. So before we enable it, we can even achieve 800 megabits. Now it's very miserable. Again, that's the weak hardware to blame. This video is a little bit longer than what I expected, just because we had to back and forth test the same thing again and again, and we need to test 4 different routers. Hopefully you get to conclusion by yourself already. For UDM Pro and UX3 Pro, no problem. They can handle all the workloads, all the settings without any problem. But for USD3 Pro and UDR, just because of the hardware limitation, it simply cannot achieve very ideal results. Of course, in real world, your real internet speed is also a factor. Okay, thanks for watching.